Today we're going to be going over operations with polynomials. This is worth about 5 points on your average SAT, but polynomials in general are worth a lot more, and the skills you learn here will be applicable to those problems too, and so make sure you know this concept. Our approach to these is going to be to identify operations with polynomials questions. We're going to break down the question. We're going to build a formula to solve them. And lastly, we're going to solve a practice question together. So how do you identify these? Well, these questions will give you two polynomials and ask you to do some operation on them. This could be addition, subtraction, multiplication, division. And what you'll do is you'll take multiple polynomials and you'll consolidate it into one. So here's our formula for operations with polynomials. Step number 1, we're going to identify our polynomial, or polynomials. Step number 2, we're going to decide which operation we're using. And then step number 3, we're going to consolidate our polynomials into one. So let's look at our practice problem here. First, we're going to identify our polynomials. So I've put a box around the polynomial that I'm seeing. There's also one on the right side of the equation, but we're going to be working with the one on the left side, so that's what I identified. Next, we're going to decide the operation we're using. So I think that we're using multiplication here because I see a polynomial split into two parts on the left side, and then on the right side, I see one singular polynomial. And so this is telling me that we're going to multiply the one on the left to match the format of the right. So here's what we're going to do. I'm going to rewrite our equation. ax plus 5 times 3x squared minus bx plus 6. It's also important to pay attention to what we're looking for here. So we're looking for ab, or a times b. So what I'm going to do is I'm going to multiply my ax term out to this 3x squared first, which is going to give me 3ax cubed. And now we're going to do it to the minus bx minus abx squared, and then do our 6 plus 6ax. Okay, so we've finished multiplying out our ax. Now let's do this plus 5. So our first one is plus 15x squared. Our second one is going to be minus 5bx. And then our third one is going to be plus 30. So now I know you're looking at this and you're saying, this looks even more complicated. We have more terms. And while that's true, let's take a step back from this problem and understand what we're looking for. So what we're looking for is AB. And we can see that we have an AB in front of our x squared term, and we only have one other x squared term here. And so what that tells me is that the sum of these x squared terms has to equal what we see in the x squared on the equation on the right side. And in front of that x squared, I see negative 7. So let's just write down what we just found out to make it a little more formulaic and work through this. So we know negative AB plus 15 has to equal what's in front of the x squared here. And just to reiterate, the reason it has to equal is negative 7 is because this negative AB and the 15 are the only terms we have in our equation that are next to an x squared, and we know that the equation above is true for all x's. So negative AB plus 15 equals negative 7. I can subtract 15 from both sides to get me negative AB equals negative 22. And here we can see AB equals 22. That makes A the correct answer. So while this one doesn't directly apply to Desmos, what you could do if you get in a pinch is take the operation you're doing on paper and just write it as you're doing it into Desmos. Desmos will show you the resulting graph from that calculation. And what you could do is you could look at the answer choices and try to see which of those answer choices equals the Desmos graph that you got by just plugging in the raw equation before doing any manipulation on it. And so do that if you need to figure out these questions. That's actually a good little workaround to figure out how to get these right if you don't know what you're doing. So good luck on this concept.